So now what we want to do is to go the other way. That is, when I give you an area under the normal curve, I want you to come back and tell me the z-score that is associated with that. And then from the z-score, go back to the x realm. Okay? So let's take a look. To qualify for a police academy, candidates must score in the, notice what we're given, candidates must score in the top 10% on a general abilities test. The test has a mean of 180 and a standard deviation of 15. Find the lowest possible score to qualify. Notice the difference in the phrasing. One, before we were asked to find the probability that you randomly select, and it's between A and B or greater than some number or less than some number. This one here is giving us a percentage, and now we're going to have to go backwards to find the x value. So let's take a look at how to do this, and then we'll formalize our steps. So again, let's draw a curve. So drawing a standard normal curve, we're asked for the upper 10%. So the upper 10%, would you agree, is going to be this part of the curve up here? And I'm just going to go 0.1. So now I have this upper tail probability of 0.1. So I need to find an associated z-score. So far, so good? Well, if this upper area in red is 0.1, and knowing that the table gives me the lower tail areas, then that means that this blue area must be how much? 0.9. So, what I need to do now is to go find an area of 0.9, and I'm going to tell you right now, there is no area of 0.9, but you're going to have to find an area that is as close as possible to 0.9. So taking a look at the tables, and again, knowing that this is an upper-tailed probability, I know I'm going to have a positive z-score. So if I just take a look and try to find a number as close to 0.9 as possible, then will you agree that 0.8997 and 0.9015 are about as close as we're going to get? And in fact, 0.8997 is closer to 0.9 than 0.9015. So I will choose this area, and then I will come back here, and it's going to tell me 1.2, and then I have to go up, and will you agree that that's going to be 0.08? So that means I'm going to have a z-score of 1.28. So this z-score then is 1.28. But we haven't found our minimum yet. We've just got the z-score. So let's recall that z is equal to x minus mu divided by sigma. Do we know what z is? Do we know what mu is? Survey says? Everybody? And do we know sigma? Yes. So what do I need to solve for? X. So I'll multiply over by sigma, and then I will add mu to both sides. So this says x equals mu plus 2 sigma. So this is something you may want to remember. So now all I have to do is plug in this stuff. So this tells me that x is equal to mu. Well, I know that the mean is 180 plus z, which is 1.28, times sigma, which is 15. So if we pop this in the calculator, we should come up with x equals 199. So now this is telling me that for somebody that wants to enter the academy, they have to take this test, and their minimum score has to be a 199. Okay. So let's note again, this one's going the other way. We're given a normal distribution. We are told an area. That means we have to go backwards and find the z-score. Once we have that z-score, we can transform into the x realm by using this guy right here. Psychologists traditionally treat IQ as a random variable having a normal distribution with mean 100 and standard deviation of 15. So here we're asked to find the 25th, 50th, and 75th percentile. Okay. All right, well, let's take a look at the 25th percentile. And let's recall that the percentile, we talked about this back in chapter 3, the percentiles, well, this is the 25th percentile, which is the same as the first quartile. And remember, the first quartile meant that 25% of the data lies to the left. So keeping that in mind, this means that if I take my normal curve, my standard normal curve, and shade this region, then that means that this area right here has to be 0.25. So I need to find the z-value. And again, I know that this z-value is going to be negative because the 25th percentile is to the left of the mean, and we know that the mean is 0. So the 25th percentile is going to have a z-score of, well, we pull up our standard normal tables. And again, we have to go into the table and find the area the closest to 0.25. So let's how much? 0.25? 0.67? Negative 0.67? So let's see, so negative 0.601227. So we have to choose between these two, so this one appears to be closest. So negative 0.67. Is that what I'm hearing? So this is negative 0.67. So now we can find the 25th percentile for this by noting that x equals mu 100 plus z, which is negative 0.67, times the standard deviation of 15. And I came up with right about 89.88, somewhere right around in there. All right, well, let's take a look at the next one, the 50th percentile. Well, the 50th percentile means how much of the data is going to lie to the left. 0.5. And 0.5 is going to correspond to 0, right? Because we know that at 0, half the data, half this mass, or half the data, or half the area lies to the left. So there's not really much to do, because we already know then that z for the 50th percentile is equal to 0. So that means that x has to correspond to 100, which hopefully goes along with the earlier part that we discussed. When you standardize, you subtract the mean and it shifts to 0. So if the mean is 100, then the 50th percentile has to be at 0, which translates to x being 100. Or if you want, it's just 0 times 15, which is still 100. Okay. And then finally, the 75th percentile. Again, the 75th percentile means is the same thing as finding what? Q3, the third quartile. Because again, we could come back and say, given this, compute Q1, Q2, and Q3. It's another way of doing this. So don't be surprised if you see that. So that means that this area to the left is 0.75. So again, we have to go into our tables and now find the area where the area is equal to or as close to 0.5 as you can get. We could use the symmetry as well. So notice that again, right here is our two numbers, and we come up with positive 0.67. Right. So this z-score then is equal to 0.67. So that means x is equal to 100 plus 0.67 times 15, which I came up with about 110.13. The score. All right, and one more example. So the average charitable contribution itemized per income tax return in Pennsylvania is $792. Suppose that the distribution of contributions is normal with a standard deviation of $103. Find the limits for the middle 50% of contributions. So again, notice that is this asking me that if I was to randomly select, what is the probability that the contribution is between some value and another value? Survey says no. Or is this giving me a percentage or an area under a normal curve and asking me to go backwards? Okay. So we want to come up with the middle 50%. So it's drawing my standard normal curve centered at 0. Then I want to find these two delimiting values where this area in the middle is 0.5. But if this area is 0.5, how much area is remaining in both of these tails? 0.5. So that means how much area is in this tail? 0.25. And how much area is in this tail? 0.25. We might need that information. Okay. So here we want to find Z1, and here we want to find Z2. Again, from the table, we know that the table is going to give me this area right here. So going into our area, we should find an area as close to 0.25 as possible, which we know that this is going to equal to negative 0.67. And would you agree that since we're finding the middle 50%, that this distance from 0 and this distance from 0 must be the same? So that means that this z-score is positive 0.67. All right, so this is then, all we have to do now is do some computation. So x equals mu. So this is 792 minus, or let's go plus, a negative 0.67 times the standard deviation of 103. So that'll give us x1, and x2 is 792 plus 0.67 times 103. So by my computation, I come up with about 722 and about 862. Does that check out? Okay.